Alright, so now we got that cleaned up a little bit. We're going to do the case capacity H2O test. So I got my helper on the side there. Going to type in the numbers as I call them out. But basically, to do a little overview, so we've got the RCBS scale here. We're going to go ahead and do a calibration. So it's been on for a while and it's been caled a few times, but just to double check, zero it out, add the 50, hit cal, add the 100, hit cal. Once it shows 100 and goes to stable, you pull them both off, and it should go to 0. There we go. So now we are fully calibrated. So what we're going to be using is the RCBS hand primer with the small primer rod in there and the 223 shell holder. So what I did is, out of the 101 Lapua pieces of brass, I figured out where my average point is, and I took some right at the average, some above and below that, here in the middle. I took some from the low end and from the high end, and then I've got my out of spec stuff here that I'm not going to be using, but I got this big bag of in spec. So these are all the good ones. They've been fully case prepped and ready to go. So to do this test, you have to use water. So I like to use the little tray that the scale came with, and then zero it out, tare weight it. That way, if there is any water that dribbles down, it doesn't get on the scale. I just use this regular syringe. It's actually for dispensing medicine, but it doesn't matter. Got a little cup of water here. Got my brass to test. And then I got my tube off of my my press. And I'm so basically using these spent primers as to plug the hole in the bottom here. Otherwise, obviously the water would just come right out. So it's a little bit more tedious doing it this way than when you're actually loading, because you got to put the spent primer there. I suppose I could load them all up in the tray, but just slide the casing in. I'm holding this backwards. Push them up like you normally would. Get a nice seal on there. So now you've added the spent primer. So what you're going to want to do is weigh it just like this, totally empty, but it's fully case prepped. So you get your empty weight. So this one is 97.8. All right, 97.8. So now let's get some water here in the syringe. Now the tricky thing about water is it has something called surface tension. And if you get into any discussion about case capacity, someone is going to bring up surface tension. And what they're talking about is kind of the way that bugs can walk on the surface of water. It's because of the surface tension. So what you want to do to try to eliminate that, along with any excess water that gets on the side of the case, is have a little towel handy to where you can dry off the sides. And I don't know if you can see this, but there's like a little bubble. It looks like it's coming across on the camera. There's like a little bubble that's doming up, which means there's actually more water there than there is capacity inside. So the trick for that is to just touch your finger to it a couple of times until that dome is gone, and you have a nice flat surface, like so. And you want to make sure there's no water droplets on the edges or anything. Then you take your water weight. So now my full weight is 127.6. All right. And it's alright if there's still some water in there, because I gotta pull those primers out anyways. So so we'll do a few more here on camera, and then we will do the rest so you don't have to watch all of that. So get it nice and tight in there. Again, putting in a spent primer. Getting the empty weight for number 2. $97.5. Get the syringe water in there. If you don't have the water droplet touch the entire rim of the mouth, you have a better chance of not getting any air pockets in there, because it is possible to get some air pockets in there. And this is why you want to do a decent sample number, not just like 2 or 3, because if you get some water pockets in there, you might not it might look like it's full, but it's actually not full. So we may have gotten some air pockets in that first one, so let's check. Alright, so that should be full right there. So again, we get that little dome sticking up, so we just touch the top a couple of times so we get a nice flat surface there. No water on the edges. So now we get our full weight. Let it stabilize. Give it a second. 127.3. And again, it's can be tough to get all the water out of there. It helps kind of if you agitate it a little bit. But see how even after dumping it out, you can still see there's water in there. So that's pretty good right there. All right, so empty weight of number 2 coming up. Number 3, yeah. So again, put in our spent primer, kind of seal it up. And it's good every once in a while to check the little tray there and make sure no water got in there, because obviously that will get heavier as time goes on if you get water in there. All right, so number 3. Empty weight, 97.4 looks like. All right. Let's try to get these bubbles in here without making any air pockets. Looks like about there. And touch it a couple of times. Make that flat on the top. Make sure there's no water on the edges. Let it settle out there. $127.3. Oh, I just dropped to 127.2. So we'll go with that. 127.2. All right, next one. Some of these are missing the little anvil inside. Like that one there. That's all right. It should still seal it up. Yep, looks good. All right, empty weight number 4. 96.7. And again, these starting weights really don't mean anything, because like you saw that you know, like if you see this one right here where you've got this primer on this side and it's missing the anvil, this one has the anvil and the spent material in there that did the explosion. So don't get wrapped up around the axle about the starting weights on these. That's why we weighed them before. What we're interested in is the delta, or the difference between the full weight and the empty weight. So we subtract the two in Excel, and then that gives us a nice chart for how much case capacity in grains we have. It's a slow process, but it's well worth it, especially if you're going to use any kind of program like Quick Load, or if you're just trying to compare. You don't really need the information for anything, but you're just trying to compare the volume in one case versus another case. All right, stabilized 126.5. So another thing to talk about while we're doing this is, some people get all hot and bothered about the water and the surface tension, and how you can never really quite be sure if you've got the exact amount of water that's filling up every crevice of this. And I kind of buy some of that a little bit, but I think the method or the process that I'm using, where I'm dropping the drops in here so they don't have a chance to grab anything on the sides, kind of removes most of the problem with that. And then plus this little trick, I learned it from somebody on YouTube, I think. I don't know who it was at this point, but about just touching your finger on the top. And you can see, I can turn, this is full of water, I can turn it on its side, and there's no water coming out. There's nothing coming out. But it's full of water. You can see it right there. So that surface tension is what's holding it in there. So, but like I was saying, some people, so our full weight is 127.6. Oh, we didn't get the...
Yeah, we didn't get the empty.
We didn't get the empty. We'll put that in the full.
Okay. What was it?
127.6. There you go. I got talking and totally forgot what I was doing there. But like I was saying, some people that want to try to get rid of that problem with surface tension, they'll use rubbing alcohol, which doesn't have that surface tension issue. And that's fine. I got no problem with that. The only thing you got to remember if you're doing that is that you compare apples to apples, and don't compare the case volume of water with the case volume of alcohol. And I believe there is a formula that you can use to convert between the two if you need to. I'm just going to get a cotton swab here and swab that out. It's pretty dry there. All right, that's good enough for government work. All right, so this is the empty weight, 97.7. I know you guys out there are like, man, how do you forget that, man? Well, this is real life. People forget things. Get over it. All right, another spent primer. Again, please don't use primers that are still good. That would just be terrible. All right, next empty weight, 97.6. Fill it up with water here. Overflowing a little bit there, that's okay. Got a little excess water, that's why I got the towel here. Dry it off a bit. These shop towels are the best thing to have in your shop. If you don't, go haze yourself. If you don't know what that is, look it up. Full weight, 127.4. Alright. Got some more of these primers here. So if you guys have any thoughts or ideas on how I can make this more efficient or make this process a little better, let me know. I'm always looking to save time and improve my process. Empty weight. $97.6. Again, try to make sure that as you're putting them in, the drops are small enough that they don't touch the entire mouth of the case around the edges and seal up, because that's where you're going to get your air pockets. And you can get different size syringes. This is probably the biggest size you want to go. Go on Amazon or go to a drugstore or something. You can usually pick up a smaller one. That's where I got this one. All right, full weight on this one. Let's give it a second. 127.5. Dropped it again. All right, so I'm gonna go ahead and pause the video here, finish these up, and then we'll move on to our next segment there. All right, dudes. So look at the numbers a little bit. So I've got them all in my Excel sheet. I'll throw them up on the screen there if I can. So we actually weighed, going back to just the weight, so the non-fired weight of the 101 Lapua that I got. And like I said, it was all within 1.88% of the average, which is pretty damn good. Our average was 95.21. 95.21 grains is the average. The standard deviation is 0.59, and the extreme spread is 2.6 grains. So it's taking the lowest and the highest, subtracting the highest from, or the lowest from the highest, and getting the 2.6. So it came out with a very good bell curve on that one. So that, again, that's the pre-fired full prep weight. So then looking at the Lapua case capacity in water, so our empty weight came in on an average of 98.02. And again, that really doesn't mean a whole lot because the varying spent primers that were put in there, some were missing parts and whatever, so that affects the weight. but then we've got an average of 127.8 full weight. And then that gives us an average case capacity of 29.81. 29.81 or just 29.8 if we're going to just the tenths place. The standard deviation is 0.06 with an extreme spread of 0.3. So I'd say that test was pretty accurate. All those numbers came out within 0.3 of each other. We did have one outlier that I just took out because it was just so far off. I think there was an air pocket or something in there. So to compare that over to the Norma, so the Norma case capacity, so there the average weight for a Norma case with a primer is 102.3. And with water, 131.8, giving us a 29.64 average case capacity. So we are gaining some capacity there. I was hoping for a little bit more capacity, but we'll have to see what happens. And then we'll also do this again after we do the initial firing and resizing and case prep again to see if it changed at all during that time. All right, so that is the H2O test and numbers review of the Norma 223 versus the Lapua 223.